Okay, let's look at this Doppler effect. Yeah, this one, this equation. All right, Doppler effect. This equation, okay, it is given in our curriculum syllabus. Yeah, CS. The observed frequency FO is equal to V plus minus observed frequency VO divided by V minus minus plus source velocity, and then multiply by source frequency. As you can see here, the positive negative sign for the top is positive negative, but at the bottom is negative positive. Why is that? Yeah, why is that? Okay, first of all, we need to identify what are these symbols. The FO is called the observed frequency or apparent frequency, and then Fs is the source frequency or the actual frequency. This is the actual frequency, source frequency given out by the source. Yeah, the frequency given out by the source, the actual one. But observed frequency is what you listen, what the observer listened. That is called the apparent frequency, and not the actual one. Okay. And then the V here is the speed of sound. Okay, speed of sound normally given by this value 343. Maybe there will be different value given in the question later on. So so normally it's 343. Yeah. That is the speed of sound. And then VO is the velocity of observer. So at the top is using observer velocity. At the top is using observer velocity, whereas below is VS, with velocity of source. If the source is moving, okay, so we have VS, velocity of source. At the top is if observer is moving. If observer is moving, then we have velocity of observer. Then we have VO. If source is moving, then we have source velocity. That is velocity of source. Okay. So the V here is just the velocity of the sound, the speed of sound wave. So don't get mixed up. Don't say that Vs is the speed of sound. No, Vs is speed of source or velocity of source. Okay. So observer is at the top. Source is at the below. Observer at the top. Source is below. Remember that. Another thing. So just now, my question is, why at the top is positive negative and at the bottom is negative positive? Why the difference? Why such difference given in the syllabus? Yeah, in our syllabus. So basically here, this is what it means. Positive means, okay, if given positive VO, okay, means for the top condition, okay, let us just look at the top first. Yeah, top. This one is plus minus VO. Plus minus VO means what? Plus VO, we put plus VO when the observer is moving towards the source. When the observer is moving towards the source. Below is when the observer is moving away from source. So remember, the top always represent the towards. Below is always represent the away. And then for the source velocity also the same. At the top is means the source is moving towards the observer, whereas the below condition is when the source is moving away from condition, away from the sound. Sorry. That means the below is when the source is moving away from observer. Okay, so the top means moving towards, below means moving away. The top means moving towards, below means moving away. Okay, to put positive and negative seems confusing. When to put positive, when to put negative seems confusing. But there is one easy way based on concept to help you to identify when to put positive or negative sign for speed of observer and speed of sound. When to put positive, when to put negative. So this concept very easy for us to determine. Okay, so I hope you to understand what's happening here. Okay, so let us first look at moving source. Actually, we have 4 situations. Yeah, we have 4 situations. Like you see, that's why we have a positive, negative, and then negative, positive. We have 4 situations. Okay. So how to put a positive, negative sign based on these 4 situations. First, we focus on moving source. Okay, moving source. The first situation is if the source is moving towards observer. Source is moving towards observer. What happened is the wave is compressed. The wave is being compressed. So what happened is when source moving to observer, the wave is compressed, means there are more wave passes through the observer per unit time. More wave passes through observer per unit time. That means the wave passes observer faster. The wave passes through observer faster. So as a result, the frequency heard by the observer increase. Okay, so you can imagine when the source is moving to observer, the wave is compressed. When the wave is compressed, more wave passes through the observer faster. So we can hear the frequency increase. The observed frequency is increased. Okay, so now how to make this observed frequency increase? How to make, based on this formula, how to make the observed frequency increase? Okay, so since the source is moving, means we have Vs. We have Vs, and Vs is at below. You see that? Vs is at below. Okay, so we have Vs at below, but we don't know what to put, what sign to put. Is it positive or is it negative sign? But our concept is, just remember this concept. When source is moving towards observer, the wave is being compressed. When the wave is being compressed, that means the wave passes through the observer faster, or more wave passes through the observer faster. So the frequency observed should increase. So to increase the observed frequency, this one, the below here, need to put negative sign, need to minus with a certain value, then only the value below decrease. Understand? So to make the observed frequency increase, here you need to put minus. You need to put minus so that the value below here decrease. When the value below here decrease, the observed frequency should increase. That's the logic. Okay, so for this case, when source moving to observer, you put minus Vs. You put minus Vs to make the observed frequency increase. Okay, so observed frequency increase. However, when the second situation, look at the second situation. Now, the source is moving away. The source is moving away. Okay, the sound emitted. Okay, the sound emitted. What happened to the sound emitted by the source? When the source is moving away, this wave is being stretched. The wavelength is stretched longer. The wavelength is stretched longer. So when the wave is being stretched, that means now the wave passes through the observer become less per unit time. Or in other words, the wave when the wave is being stretched, now the wave passes through the observer slower because less wave passes through observer per unit time. So when less wave passes through the observer slower and is slower, that means the frequency heard by the observed frequency should decrease because the wave now passes through the observer slower, less wave. So the observed frequency should decrease. So what to put here? The sign positive or negative? Vs. So our reasoning is our observed frequency should decrease. So to decrease the observed frequency, the value below here need to increase. Because the value divided by a bigger value become a smaller value here. Understand? So, how to make the value below here bigger? So we need to put plus Vs, positive Vs. So when we plus Vs, the value below here increase, so the observed frequency decrease. Understand? So here we put positive Vs for when the source is moving away from observer. When source is moving away from observer, the wave is being stretched. Now less wave passes through the observer, slower, so frequency decrease. So below here you need to put positive Vs to divide by a bigger value. Divide by a bigger value, become a smaller value. So in short is, if you want to make the observed frequency increase, below here need to become a smaller value. How to make a smaller value? You minus it. So this one here below here become a smaller value. You divide by when the value divide by a smaller value, become a bigger observed frequency. Okay, and here how to make the observed frequency decrease is we put positive Vs. Positive Vs, that means the value below here increase. Now the value divide by a bigger value. The observed frequency become decrease. So that is a reasoning. Very simple. Okay, the value divided by smaller value become a bigger value. The value divided by bigger value become a smaller value. That's it. Okay, now look at the third and fourth situation. The third situation is, just now we are talking about what? We are talking about moving source. That means the source is moving towards or moving away. Is moving towards observer or moving away from observer. But the observer is stationary. Now we make the source stationary. That means the one who emit the sound becomes stationary. The observer is moving, either moving towards the source, or observer is moving away from source. Okay, look at the first one. Now if the observer is moving towards the source, what happened? The observer is moving towards the source. The wave emitted by the source now passes through observer faster. It's just like the sound wave is moving in the opposite direction. Observer is moving towards the incoming sound wave. You understand or not? This sound wave is emitted by the source. Now this sound wave is moving towards observer, and the observer is moving in the incoming direction. Moving in the opposite direction. So surely the wave passes through the observer faster, because the sound wave moving towards observer and the observer also moving towards the sound wave. They are moving in the opposite direction. So the sound wave emitted by the source surely passes through the observer faster. So what happened is, since more waves passes through observer faster, the observed frequency should increase. Okay, and now we know that the VO is at the top. The velocity observer is at the top. So what now? We put, for this one, the observer moving towards the source, we should put positive or negative VO. So our reasoning is this one. The wave passes through the observer faster. Our reasoning is, since the wave passes through observer faster, the observer hear a higher observed frequency. This observed frequency increase. So that means VO is at the top, not at the bottom. Okay, at the bottom is Vs. At the bottom is source velocity. Observed velocity is at the top. Okay, so now observed frequency is increased. How to make this observed frequency increase? That means at the top here, this one need to become a bigger value. So to get a higher observed frequency, the value be at the top here need to become bigger. Not like last time. The value below here need to become smaller in order FO to become bigger. Okay, because this one is divide. This one, the value below need to become smaller. But for this one, the VO is at the top, not at the bottom. So the value at the top here need to become bigger in order FO to become bigger. So the difference is this. Last time is the value below here need to become smaller in order FO to become bigger. This time, the value at the top here need to become bigger in order FO to become bigger. So this one we need to, how to make this value become bigger? We plus VO. We plus VO. So when we plus VO, the value at the top here become bigger. So our observed frequency increase. Okay, observed frequency become increase. Okay. Now that's for the third situation. Now for the fourth situation is, if the observer is moving away from the source, what happened when the observer is moving away from the source? Now, if you observer is moving away from the source and the sound wave is also moving towards the observer, it's like now the sound wave is trying to catch the observer. But the observer is leaving away. So now, if the observer is moving in the same direction with the sound wave, so it's like the sound wave is trying to catch the observer. So the wave passes through the observer slower because your observer is moving away from the sound wave. Understand or not? This one, at the top here, observer moving towards the source is observer is moving towards the sound wave. Towards the sound wave, the sound wave is moving towards the observer and observer moving towards the sound wave. So you are moving towards the sound wave, so the wave passes through observer faster. But now, if the observer moving away from the source, so you are also moving away from the sound wave. If you are moving away from the sound wave, the wave passes through the observer much slower. So the frequency heard by the observer should decrease. Understand or not? Because the wave passes through the observer slower. So the observer will hear a lower frequency or lower observed frequency. So now, this one should put positive or negative VO, okay, to get a lower observed frequency. This is all just mathematics. So to get a lower observed frequency, to get a smaller value, the value at the top here need to become a smaller value also. A smaller value at the top here, you will also have a smaller value FO, observed frequency. So how to make the value at the top here smaller? We minus lah. We minus VO. So value at the top here becomes smaller. So observed frequency becomes smaller. Understand? So that's all for for this fourth situation. How to identify when to put positive or negative VS, and how to identify when to put positive or negative VO. Okay, so there's one similarity between this moving source and moving observer. You look at the similarity here. Okay. Okay, listen carefully. When the source is moving towards the observer, or the observer is moving towards the source, both situation, the more wave will passes through observer faster. Say more wave passes through the observer faster. This one also more wave will passes through observer faster. The first one is because the wave is being compressed when the source is moving towards observer. Compressed. So surely when wave is compressed, more wave will passes through observer faster. So you hear a higher observed frequency. Similarly, for observer moving towards the source, you are actually moving towards the sound wave. Moving towards the sound wave, moving towards the incoming sound wave. Naturally, the sound wave will passes through observer faster. You will also hear a higher observed frequency. So, in a nutshell is, either the source is moving towards observer or observer moving towards a again, either the source is moving towards observer or observer moving towards the source, moving towards. No matter it's source moving towards or observer moving towards, both observed frequency should increase. Both observed frequency should increase. Okay, so for Vs, since Vs is below, you need to minus to make the value below here become smaller in order to make the FO become bigger. But VO is at the top. VO is at the top, so you need to put positive VO. You need to plus VO. So to make the value at the top bigger. Value at the top bigger, so FO will naturally become bigger. Okay? So that's why here value at the below here put negative, value at the top here put positive. Okay? Okay, let's look at the next one. Now, if you look at here, if the source is moving away or the observer moving away, source moving away or observer moving away, both will have the observed frequency decrease. Observer frequency decrease. Source moving away makes the waves stretch bigger wavelength. So less wave passes through the observer. The wave passes through the observer becomes slower, so the observed frequency become lower. And whereas the observer moving away is you are moving away from the sound wave. You are moving away from the sound wave, so the wave also passes through the observer slower, so you hear a lower observed frequency. So no matter it's source moving away or observer moving away, the observed frequency should decrease. The observed frequency should decrease. Okay, so for the first one, how to make the observed frequency decrease? Okay, Vs is at the bottom. Vs is at the bottom. So to make the value smaller, to make this value smaller, the bottom here need to become bigger. So we put positive Vs. But this one, VO is at the top. Observe, VO is at the top. So to make this value become smaller, here you need to make the value smaller also. Need to minus. Okay. So in short, what I can say is, to make the FO decrease, if the Vs is at the below, so below here you need to plus to make the value become bigger. So divide by a bigger value become a smaller value. But VO is at the top, so the top value need to become smaller in order FO become smaller. So at the top here need to minus, so become smaller. FO becomes smaller. So that's the difference. That's why I got difference in positive negative between source and observer. Okay, so in short, what I can say is no matter is source moving towards observer or source moving towards, no matter is source moving towards or observer moving towards, the observed frequency always increase. Observed frequency should always increase. And then for source moving away or observer moving away, the observed frequency should always decrease. Okay? Moving towards, observed frequency always increase. Moving away, observed frequency always decrease. That's it. Another thing to note here is if the source is moving, only the wavelength of the sound wave will change. Either it's compressed or it's being stretched. If being compressed, like source moving towards, the wavelength is being compressed, so the wavelength decrease. But when the source is moving away, the wavelength is being stretched, so the wavelength increase. Okay. However, if the source is stationary, only the observer moving towards or away. If the source is stationary, the wavelength is always constant. Okay. So that's it for Doppler effect. Okay, no matter is source moving towards or observer moving towards, the observed frequency always increase. But if source moving away or observer moving away, the observed frequency always decrease. Okay, and that is how we determine the positive or negative VO or VS. How to determine the positive and negative VO or VS? The difference is VO is at the top, but VS is at the bottom. That's why got different sign. Okay, because one at the top, one at the bottom. That's why here become positive negative and here become negative positive. That's the reason. Okay, so now we go to the problem solving videos. Bye.